Good day, class. Today we're going to be going over using the draw.io tool to put together a flowchart from the algorithm pseudocode that you created in step 2 of the 5-step programming process. In module E of the lesson in week 1, I have a link to a class exercise that we're going to be working on over the course of the next few lectures. And in that class exercise in module E, there is an exercise of a problem we're trying to solve, and we're going to go through the process of going through and explaining steps 1 and 2. So if you have that document, you'll notice that the task that we're trying to work through is to determine the retirement age of an individual and if they're eligible for retirement. Now, typically in the United States, there are technically 3 ages in which someone can retire. We're just going to make an assumption to try to keep the problem simple that they have a retirement age of 65. So what we're going to do is we're going to be writing a program that will determine if an individual is eligible for retirement. So that's the task. And so in step 1 of the 5-step programming process, our job is to specifically define what the problem is. And so if you take a look at the document, it shows that step 1, we're first going to, based on the user's birth year, we're going to determine whether or not the individual is eligible for retirement with an assumption that the retirement age is 65. Now, throughout this document, you may see a couple of 2 or 3 times where it says that we reference the user's approximate age. And the reason why we call it an approximate age is depending on when the person was born in their birth year. The person may be 25, they may be 26, depending on when the calculation is done. So we're looking to get an approximate age in terms of how old that person is. And so for this particular problem, what's going to happen, we're going to ask the user for their birth year, we're going to ask the user for the current year, and we're going to do a calculation to determine how old their approximate age is. And then we're going to determine whether or not the user is eligible for retirement based on a retirement age of 65. In the problem statement, it states that if they are not eligible for retirement, the program should output the number of years until retirement. And if they are eligible for retirement, the program should output an appropriate message. So in step number 2, what we're going to do is we're going to look at the individual steps that are necessary. We're going to generate our algorithm. And part of the algorithm that we're going to be generating involves declaring and initializing variables. The variables are going to be used to hold data that we're going to be using within our program when we get to step 3. And it's a very specific step-by-step process, starting with a start and ending in an end. And each line in between represents typically one task that the computer is going to do when we actually have our Python code written. So starting at the top of the algorithm, we start the algorithm with a start. Typically, every program is going to have a start and a single end. The first thing we're going to do is display the purpose of the program, because if you're running a program and all you're doing is having a flashing cursor, it's not going to make any sense for the user. We got to think from the perspective of the user. So we're going to display a simple purpose statement. And then the program, what we're going to do is we're going to have the computer declare and initialize variables. Now, the declaration of a variable is just to tell the computer that there's going to be a memory location assigned a name that's going to be used to hold some form of data. Now, in Python, it's not really required that you declare and initialize variables up front, but it is proper programming protocol that you tell the computer the kind of variables that you're going to use, and initialize them with some specific values so we know as programmers specifically what data is in the memory location that is associated with the variable that we're planning on using for a program. So if you noticed, I have 5 variables that I plan on using in my program when I write it at step 3. And so I've already created those variable names so that there's no problem in generating the program once I get to the formal programming stage in step 3. So the real first task that I'm doing as far as input is I'm going to ask the user for the current calendar year, because based on the calendar year, we need that calendar year to determine what the person's age was based on their birth year. So the next piece of input I need is the birth year of the individual. And then I'm going to have the computer do a calculation to calculate what the user age is. And typically what that is the current year minus the birth year. Then I'm planning on displaying the user's calculated age. And then I'm going to calculate a delta. And we'll talk about that a little bit, because one of the tasks that we need to do is once we display the person's calculated age, we need to determine if that is going to mean that they are eligible for retirement or not based on a 65-year retirement age. So the strategy that I used was to subtract the user's age from the retirement age. Now, if you think about it, if the person's actual age was 65 and the retirement age is 65, they qualify. So what I did was I used a variable called delta, and I calculate the difference between user age and retirement age. If we take the user's age and subtract the retirement age, if it's equal to 0, that means they're eligible for retirement. If the person's age is greater than 65, let's say they're 66 or 67, and I subtract 65, the delta is going to be some sort of positive value. So if I have a number 0 or greater than 0, that means that the individual is qualified as retirement age or retirement qualified. If not, we have a situation where the person's not quite there yet. So if the person's age was 50 and the retirement age is 65, that means if we subtract 65 from 50, we're going to get a negative number. And if we have a negative result or negative delta, that means the person is not eligible for retirement and they have a certain number of years to go. All right. So with that in mind, we're going to generate our solution. And with that, I'm going to be using the Draw.io application. Now on the screen is the Draw.io application. So you can navigate to the Draw.io set of tools by going to the URL listed on the browser that you're seeing. That's www.draw.io. And once you're here, what you're going to be doing is choosing the device option. And once you do, we have a choice to make. And since we're dealing with a brand new flowchart, we're going to be choosing the first option, which is create new diagram. Now, once your diagram is created, or if you weren't able to finish it, you can save your file and then you can open it up again to continue, but we'll get into that at a different time. So let's go ahead and create a new diagram. And there are a number of options that are available here. We're going to go through one of the options, and it almost seems to make logical sense to choose flowcharts, but we're not going to choose flowcharts for a couple of reasons. Primarily because one of the options that happens when you deal with flowcharts is that you can pick one of these templates that are already available. The problem is you have to delete the symbols that you really don't want, and that takes more work than actually creating the flowchart from scratch. So we're going to choose the basic diagram, and then what we're going to do is we're going to change the name so that we can customize this to what we want it to be. So in the case of our class exercise. I'm going to put my last name followed by class exercise 1, step. I'll just use class exercise 1. That should be good. And then we're going to choose create. Now what you're given here is a blank grid. It looks like a piece of graph paper. For those of you who remember graph paper several years ago, you have this grid of lines and individual boxes, and the diagram is the graphing paper is just there to help keep your diagram clean. So if we look at our pseudocode on the sample problem that we've been talking about as far as determining eligibility for retirement, we have to start off with specific symbols. And in step 2, the first step of pseudocode is start. Now, what I'm doing is I'm referencing the additional documents on the class Moodle site in Module E. I provided 2 specific documents in addition to the 5-step programming process. One of them is using draw.io to create flowcharts. You can look at that when you need to. But the other document, which is going to help us in our creation of the flowchart, is the flowchart symbology. So I'm going to assume you've had a chance to review that. And what we're going to do is we're going to start our process. So the first thing that I'm going to do is I'm going to put a block of text in. And on the left-hand side, there's a series of symbols that are available to be used. I'm going to choose text. And I'm going to choose, I'm going to put some information in here that is going to include my last name, flowchart for class exercise 1. And what you can do is you can increase the size off on the right-hand side. So the left-hand side, you pick your symbol. You can place it any place you want on top of the graph or the chart, or the graph paper, and then you can modify the characteristics of the information and modify the size, and we're basically ready to go. So the first piece of pseudocode that we've got in dealing with this program is we're going to go ahead and choose the start symbol, which is the oval. And I'm just going to put some wording inside of this. You don't have to completely enter the line of pseudocode, but some reference to it. So I'm going to put the word start inside of a first symbol. And you can even modify the individual symbols. My recommendation is just to take the symbols and put them in. And then what we can do is we can actually put the arrows in a little bit later on. So I'm going to go ahead, and that takes care of step number 1, start. The next piece of pseudocode we have in our solution is to display a program purpose. Now, display references output. So if you take a look at the symbology document, it shows that the parallelogram is what's used for our output function. And as you click and drag the parallelogram over to the flowchart area, you can place it to where we need to. And as you begin to move it, you'll notice that you get a line that shows you're in alignment with the previous symbol. And I'm going to try to make it so that there's about 1 block of space in between each of the symbols to try to keep it neat. So inside here, I'm going to put what this particular output is supposed to do. So display program purpose. Okay. So I'm going to go through and continue the next piece. And the next piece that we need to deal with is to initialize and declare the variables. So the declaration of variables and the initialization of variables, it's actually an assignment. So we're going to have a variable assigned a particular value. Now in Python, the way that you actually assign a variable is you have the variable on the left and the value you would like to assign the variable on the right. And in between is an equal sign. Now the equal sign in Python is referred to as an assignment operator. So since we're assigning a value to a variable, that's referred to as a process because the microprocessor is going to have to take that responsibility of taking a specific value and placing it into the memory location that's assigned for the variable we're planning on using. So a process variable is a rectangle. So I'm going to grab our rectangle and I'll place it where I need to. And we'll put that in alignment. There we go. Okay, now what's neat about this program also is that if you want to go through the process and make it a little bit more finished or refined, once I pick a symbol, I can pick a color. My suggestion would be to keep the inputs and outputs, well, inputs a certain color, the outputs a certain color, processing a certain color, decision making a specific color, so that when you see the color, you can associate it with the particular function that it needs to be dealing with. So let's go through and I'll assign green to our processing variables. So in this particular case, the first initialization that's going to occur is retirement age equal to 65. Now you may be looking at these variables and wondering why there's no space. There's a capital starting on the second word of that two-word variable, retirement age. What I'd like you to do is to follow what's referred to as camel case format. And camel case format says that you start with the first word all lowercase, and every subsequent word in the variable is going to include a capital first letter. So it looks like a little bit of a hump, if you will. Okay. So one of the requirements is that we're not going to include a space in between the words. If you need to push the space implication, you can use an underscore. But in this case, I'm just going to use the two words of the variable retirement and age put up against each other with the second letter of the variable, of the first letter of the second word of the variable capitalized. That's why we have the retirement age listed this way. Now, this is the format of how you want the variable to hold a value. In this case, what we do is we're trying to put the value 65, and we're going to assign it using the assignment operator to the variable retirement age. So the next thing I'm going to do, since we've chosen green as our color, I can choose to copy this and paste it so it has the appropriate format. So I'm going to take that. Notice that it just copied. And so what I'm going to do is I'm going to move this down. Okay, and so I can now change this. So the next assignment is going to be just to initialize user birth year. So since I don't know what the user birth year is going to be, I'm just going to assign the user birth year following camel case format. Notice that each word in the variable, the first word, user, is all lowercase. Then the B from birth and Y from year is capitalized, maintaining camel case format. So then I'm going to take and move this one down, and I'm going to change this variable to current year equals 0. And I'm going to pull this one down. This is going to be user age is equal to 0. Since these variables are going to hold numerical quantities, specifically, they're going to hold integers, I'm going to initialize these variables to 0 or something else. You'll notice that retirement age was set at 65 because we know that the retirement age is equal to 65. If we wanted to initialize a variable to hold a word, we can do so by initializing the variable with double quotes. And when we get into that at a different time, I'll show you some more information about that. The next variable is delta is equal to 0. Okay, so let me go through and put some arrows in here since we're planning on using this particular symbol. And what I would like to do is go ahead and turn this, take the endpoint and drag this up so I can show flow and place it right there. And I'm going to take my arrow and I'm going to copy it and then paste it. I can put it between the variables. I'm going to repeat that. And copy. I'm going to grab that. And a few more. I'm actually doing is pasting these, deselecting them, and then grabbing them. So now we have, what we've just done was we've actually generated a flow chart that shows the logical program flow start. The next thing to do is to display the program purpose, and according to the algorithm, we're going to declare our variables and initialize the variables to specific values. This way, Python is going to know that I have these variables that are going to be used to hold some sort of data. The next thing it says to do in the algorithm is to ask the user for the calendar year and the birth year. Now, this is input, and according to the flowchart symbology, the parallelogram is being used to denote input. So I'm going to go ahead and place that input symbol, and since I need two of them, because I have one for the calendar year and one for the birth year, what this is going to allow me to do is I'll go ahead and put that block in. And since this is input, now this is output. I've denoted blue for output. I'll choose a different color for, I don't know, I'll choose this orange color, whatever it is. And I'll put that in. And so for this input, ask user for current year. Now, if that bothers you as far as the format that the words are being outside of the box, you can always come into the text and you can press enter so you can push that so that it appears inside the box. So I'm going to go through, and this one is going to say ask user for birth year. And I'll connect. You can copy that. So I'm going to grab that. I'm going to grab my arrows and start building that. Okay, so if you'll notice, I'm running out of room. There's a lot more to the page. If you look to the right, there's more space in this white area here, but I'm running out of space at the bottom here. And it's to try to keep it clean. What I'm going to do is use a new symbol, and I'll show you how this works. I'm going to use a connector symbol, which is a simple circle. So I'm going to grab this circle and place it right underneath where I want to connect. So I'm going to put my arrow in, and I'm going to put that in. And what I'm going to do in here, I'm going to put the letter A. Now, you can call it anything you want, but with the A in here, what this signifies is that I've run out of space. And so what I'm going to do is I'm going to now move to the next column. I'm going to place another connector in here and put some space in. And you notice that the lines come up to show you where you are. And inside here, I'm going to put the letter A. And logically, what this means is that the flow of the program goes from start to display purpose, initialize the variables, ask the user for the current year, ask the user for the birth year, and now we have to find a matching A. So if you take a look at the flowchart, we scroll to the top, and there's our connectors. So what I'm going to do now is I'm going to copy this arrow and paste the arrow and move this right underneath where we have what I'm doing. Okay, so we're running into some time issues here. So let me go through and finish up the creation of the flowchart. I'll do it a little bit quicker. Next thing we're going to do is calculate, which is a process. And then we're going to display the user age, which is a parallelogram. And then we're going to calculate, which is another. Good. Okay. So put my arrows in. I'm going to create my color scheme. This is going to be a display, which is blue. The colors really don't mean anything other than just for consistency. So calculate user age. Looks like I have to move this box down. And display user age. And then we're going to calculate the delta. Calculate delta between user age and retirement age. Now, once this is done, we have to make a decision as to what we're going to do. We mentioned before that if the delta between the user age and the retirement age is a positive number, so let's say for the sake of discussion, if the person's age was 70 and the retirement age is 65, the 65 from the 70 is 5. So as long as that number is 0 or greater than 0, we're going to state that the person's eligible for retirement. If not, we're going to display the number of years until they can retire. So we have a path shift here. It depends on some sort of criteria. It depends on what? It depends on delta. So we have a new symbol we're going to be introducing. It's based on a decision. But before we can do that, I think I might need to move this second branch over to the right a little bit. So what I'm going to do is I'm going to put I'm going to highlight around the entire block. And when I do this, I can take the entire block and move it. Okay, that's the benefit of actually harnessing or lassoing. So I'm going to click and drag outside the region. You highlight around and it selects all the pieces. You take your mouse and you put it inside and you can move it any place you want. All right, so this should be fine. Okay, now depending on what delta is will depend on what we do. So what that depends on, it's going to require a decision that has to be made. If the value is greater than 0, if delta is greater than 0, the person is qualified as retirement. If the delta is less than 0, that means that the person still has to work. So let's use our diamond, and we'll put our diamond symbol here, and we have 2 branches. So let's put our connector, and we're going to take our connector and we're going to put it in to make sure it lines up. And I'm going to actually take this, I'm going to make it a little bit larger because I want to put some information in there. So I'm going to move this over a little bit. And okay, so what's inside the box? What's critical here is to know that, again, we have to understand that we're going to do a calculation to determine whether the person's qualified for retirement or not. And we said before that if the delta is greater than or equal to 0, that means that they can retire. So our test is going to be, is delta greater than or equal to 0? So I put the 2 symbols greater than and equal to next to each other because there isn't a key on the keyboard that actually shows the greater than or equal to. So we said before that if delta is greater than or equal to 0, that means that the individual is qualified as retirement, as qualified as being able to retire. So what I'm going to do is we have to display, if the delta is greater than or equal to 0, we're going to display that the person can retire now. So that's an output. That's a parallelogram. So I'm going to put that right here. Okay, so display you can retire. That's the message that I want to display on the screen if the user can retire. So let me clean this up a little bit. I'm going to go ahead and make our symbol red. Our outputs are blue. And then we have to come up with an arrow. So you can do this a couple different ways. I'm going to go ahead and take my arrow and I'm going to move it. I'm going to take it and move it. And then I'm going to take the endpoints and I'll connect one endpoint there, one endpoint here. And then if you take the center and pull it out, now you have what looks like a clean arrow. As a matter of fact, this one hasn't hit yet. So we can click it to the left. And as soon as it does, you'll see a green dot appear. And you know that that's the connector. All right. So this is the yes branch. Okay. So is delta greater than or equal to 0? I'm going to take a piece of text and I'm going to move that up here and put the word yes. So here's the decision process. We're going to calculate delta. Is delta greater than or equal to 0? Yes, we follow this branch and display you can retire. We're going to have an equal branch coming off on the no side. So what I'm going to do is I'm going to take and copy this symbol and place it. Looks about right. And I'm going to take my arrow and place my arrow. I got to move my arrow up. And I'm going to take my arrow and connect it to the triangle, take my end point and connect it to the box, and take my middle point and stretch it out. Might not be perfect, but it'll work. Now, what's inside here is to display years to retire. I can clean that up a little bit. And we're almost done. So depending on what happens here, according to our pseudocode, is that once I do either of these, and if you really want to, we can take this and we can put the word no on this side to signify what's going to happen if this doesn't work. But regardless, one of these two conditions is going to display. And so what we're going to do is we need to come back, we need to have an end. And so the way we're going to do that, we're going to take a connector and we're going to place it right in the center. And we're going to have another arrow. And we're going to take our arrow and we're going to have our arrow connect to our connector and take our center point and stretch it out. And then we're going to take another arrow and connect our arrow to our symbol and then stretch it out. And then we have one last symbol that we need to make this program complete, and that is the symbol for stop. I'm going to steal an arrow here and place it in. And let's see, we didn't color this symbol. We can do purple. And purple, and we're going to say end. So there you have it. We have our flowchart that we actually have for our pseudocode that we've created. Each line is associated with a specific symbol. Each task is unique. This is the next step in this programming process. And once you have this done, what we can do is you'll notice that it says to save changes. So when you go ahead and click to save, what it's going to do, it's going to download your file, your flowchart file, to your local machine. Now, that file is in a format called XML. The XML format contains all the information necessary to reconstruct this particular flowchart in draw.io. So in Google Chrome, which is what I'm using now, the file was downloaded to the downloads folder. So your machine may be different, but I'm using Google Chrome. It goes into downloads. But I want to show you another form. If this is complete and you want to output in a different format, what you can also do is output it as an image or a PDF file. So under File, you can choose Export As, and I'm going to go ahead and choose JPEG, because JPEG will allow me to import the flowchart into a word processor, and it pulls it in as a picture. You can't modify it, but it does pull it in completed, and you can use it in a document. So I'm going to go ahead and choose JPEG, and I'm just going to keep the selections the way that they are. I'm going to choose Export, and This is the name it's going to be given. I'm going to keep it the same name, but then I'm going to choose download, and it downloads the JPEG version of the flowchart. I can do the same thing for the PDF version. So I can do an export as PDF. And I'm going to go ahead and choose export and download. Now I actually have a version that's available in the PDF format. Okay, so what I'm going to do now is I'm going to close out of this flowchart, and I want to show you how we can reopen it up from the Draw.io application. So I'm going to go ahead and choose close. Now, once you do that and you still are in the Draw.io application, this time what we're going to do is we're going to open up an existing diagram. So once we do that, we can choose Open Existing. And one of the things that I was sharing with you is that we have the Draw.io application, which is the XML file. I'm going to double click on the XML file, and it reopens the flowchart into Draw.io so I can make any modifications or additions that I need to. And that's about it. Good luck. I suggest you try doing the exercise on your own. This way you can get familiar with how to use the Draw.io application.